Imagine having eyes so big they cover almost your entire head. Now imagine each of those eyes is actually made of nearly 30,000 tiny eyes, all working together. That's not science fiction. That's just a normal Tuesday for a dragonfly. Today we're diving into one of the most insane visual systems in the animal kingdom. This is how dragonflies see the world. A dragonfly's head is almost entirely eyeball. Each of its two compound eyes is made of up to 30,000 individual units called ommatidia. Tiny lenses, each one capturing its own little piece of the world. Put them all together and the dragonfly gets a mosaic view that covers nearly 360 degrees. There's almost no blind spot. Something could sneak up behind a dragonfly, above it, below it, and it would still see it coming. Compare that to us. We've got two eyes pointed forward, giving us maybe 180 degrees if we're generous. A dragonfly is basically wearing a built-in panoramic camera rig, permanently switched on. Humans see color using three types of light-sensitive proteins, opsins, tuned to red, green, and blue. That's already enough to give us millions of colors. Dragonflies don't have three opsins. Some species have up to 30. Scientists still don't fully understand what a dragonfly's color world actually looks like, because we don't have anything to compare it to. But with that many channels, they're likely picking up ultraviolet light, polarized light, and shades of color that don't have names in any human language. Some researchers think different parts of a dragonfly's eye are even tuned differently. The upper half built for spotting prey against open sky, the lower half built for tracking movement against cluttered plants and water. It's less like one eye and more like two completely different visual systems stitched into a single head. Here's where it gets really wild. Dragonflies are among the most successful predators on the planet. Some studies put their hunting success rate above 90%. For comparison, a lion is lucky to succeed one time in 4. Part of the secret is a neural trick called selective attention. When a dragonfly locks onto a single flying insect in a swarm, specific neurons in its brain essentially mute everything else. The other 100 bugs buzzing around basically disappear from its focus. It's not unlike how a human can lock onto one voice in a crowded room, except a dragonfly is doing this in midair, at full speed, while also predicting exactly where its target is going to be a fraction of a second from now. That prediction is key. The dragonfly's brain doesn't just track where the prey is, it calculates an interception course, adjusting in real time so it's not chasing the bug, it's meeting it. All this visual processing would be useless without a body that can keep up. Dragonflies can fly in every direction, forward, backward, sideways, and can hover in place like a helicopter. Their 4 wings move independently, letting them make split-second turns that would rip apart most other flying insects. And their vision updates fast, really fast. Where humans process roughly 60 individual images per second before it blurs into motion, some dragonflies can process well over 200. The world, to a dragonfly, moves in slow motion. That's part of why they're so hard to swat. By the time your hand starts moving, the dragonfly has already seen it coming, calculated an escape path, and started reacting, all while you're still mid-swing. Vision even shapes how dragonflies find each other. Males often stake out territory near water and rely on sight alone to spot females flying past. And to spot rival males, they need to chase off. Some species have wing patches or body colors that exist almost entirely to be seen by other dragonflies, a visual signal for species recognition, so they don't waste time courting the wrong species. When a male finds a mate, dragonflies form what's called the wheel position. The male grips the female by the back of her head, and she curls her body around to connect with him, forming a loop shape while still in flight or perched. It looks bizarre, but it's built for precision. Males have a specialized structure that lets them remove sperm from previous mates before passing on their own, meaning competition for mates continues even after pairing up. In some species, the male stays attached afterward, literally guarding his mate while she lays eggs, to make sure no rival gets a second chance. 300 million years ago, ancient relatives of dragonflies were flying through prehistoric forests with wingspans over 2 feet wide. The core design, the huge compound eyes, the almost 360-degree awareness, has barely changed because it already worked. Evolution found a nearly perfect hunting machine and just kept refining the details. So next time you see a dragonfly hovering over a pond, remember, it's not just looking around. It's running 30,000 lenses, dozens of color channels, and a predictive targeting system, all in a brain smaller than a grain of rice. That's how dragonflies see the world, a reality built from nearly complete awareness, colors we can't imagine, and a hunting system so good it's inspired actual military drone targeting research. If you like seeing the world through different eyes, check out how octopuses or jumping spiders see it too. Links on screen. And subscribe if you want to keep exploring how wild vision really is out there.